I'd like to welcome everyone to the AO Journal Club on femoral shaft fractures.
So if you could just, you mentioned earlier that this was, you view these papers kind of as all together, these studies together. Can you put that in context for me on what this and its sister or brother papers meant to you, or what the impetus was for these?
Sure. Back in the 90s, we had made the shift from just nailing femurs to static locking femurs. There was a concern back originally that static locking would be too rigid and the femurs wouldn't heal. Now we can static lock everything. At least I believe that's the standard of care. But we went through a series of nails with different types of nails that were more dynamic in nature, and we saw a shortening in failures. So everything was being statically locked. And the next step was, well, what can you do with the multi-trauma patient that has this injury and this fixation in it? In other words, we had people who had injuries of bilateral lower extremities who couldn't get out of bed if you weren't going to let them weight bear at all. So the more that we did static interlocking, and yes, we were using 2 screws all the time back then. But the more that we did static interlocking, we saw that there was a select group of patients who needed to use that leg for mobility early on. And sometimes people have misconstrued this in that the patients that get a femoral nail that's static interlocked are going to just dance down the hall like they don't have an injury. They don't. They have muscle injury and periosteal pain and fracture and so forth. So they don't go crazy, but allowing them to weight bear early gets them up and gets all the positive things of mobilization of the patient, not just cost, but out of the hospital earlier. But I believe it's good for the patient anyway. So we wanted to see if static interlocking led to healing, or did it deter healing, and found it did not. And then we went ahead to say, well, can we go ahead and push the envelope and let these people weight bear?
Okay. So what was being done at the institution? Is it what you described in the article, or was this considered even aggressive, or was there pushback among your partners versus the greater orthopedic community in the United States and North America?
I think we were actually, in some ways, we used for a while a thing called a Brooker-Wills nail, which had these fins that came out. We used that probably too long, and that did allow some shortening. So we went to the static interlocking, and we're very happy with the amount of callus and early healing. I think in terms of weight bearing, most people did not do that, and I think that this was at that time when even femoral nails and interlocking nails were just becoming a big community thing, where a lot of these people were in trauma centers, and so they were being looked at people like us at Shock Trauma, whereas the community, I don't think, would have been out there allowing their femoral fractures to weight bear. And so in the patient with an isolated femur that maybe didn't make it to Shock Trauma in Baltimore, I think that patient was put on crutches and probably put toe touch or foot flat non-weight bearing by the community. I think that the takeaway, in my estimation, was that, oh, just go ahead and let them walk. And I think that that's not reality. I think that when we said you can weight bear these after injury, it doesn't affect healing, and your loss of fixation is really very, very unusual to occur. I think that it's like reading the headline and not reading the article. I'm not sure we even understood it. We were looking to really change the way the postoperative care was given. And so we kind of let that go on a little bit, where people say they could weight bear. But anybody who's treated femoral fracture, people with femoral fractures, knows, again, they're not walking down the hall with a cane the next day. They hurt, they just are not, their muscle simply can't hold them up. It's been torn. Think about what happens every fracture you open up to do an open reduction. You look at that muscle and you go, well, it's obviously been injured. It's not easy for them. So I think the reality was that these people were able to protective weight bear and maybe help use their legs, some cases just for stand pivot transfers to get out of a chair, sometimes to be able to shuffle across the room to the bathroom. It was not as if these people were riding exercise bikes with full knee range of motion, getting their strength back at 3 weeks out. They just aren't. It's just too big an injury.
No, that's good. In terms of the biomechanics portion of the study, do you think if you redid this today, what materials would you choose to use, and how would you do it differently if so?
Oh, that's a great question. We were using back then stainless steel devices, and obviously most of the devices now are titanium based. So I would certainly do that differently. And the other thing is, now that I've had experience with this over time, what I found was, and it's not really in the paper, is that there's an alpha screw. One of the two distal interlocking screws becomes the one that really bears most of the weight. You think that you've got them both through across the distal femur, and they're both through the nail, that they're sharing weight equally just because they kind of looks the same. They're not. And one will break before the other every time. You hardly ever see two break at once. I can't imagine that I've seen that very often in my life. And that's hundreds and hundreds and hundreds of femoral fractures that we looked at. So I would probably try to devise this study to see, would I do it with just one screw? Yeah, I would. And would I do it with two screw configurations to try to figure out how you get that alpha screw and how you get the non-alpha screw. The alpha screw is, what I mean by that is that's the one that's really doing the resistance to shortening. That's the one bearing the weight through the nail screw bone construct. That was one of the things I think I took away from it, that obviously it was a conclusion that was well after the paper was done.
Okay. Synthetic femurs, were those in existence at that point, or would you still use a similar substance to pop the implants in now?
We had long discussions about that. We had, at the University of Maryland, we had a huge cadaver availability. So we could have done cadaver femurs, would have really upped the expense, but it also would have thrown in the variable of bone density. And then we would have had to get bone densities on everyone. So this is really a test of the screws. We both have seen screws that windshield wiper back and forth a little bit. Obviously, that's a screw bone interface failure versus a rod screw failure. We were concentrating on the rod screw failure, even though I think the other exists and the other is important. And I would do something different to try to bring that variable into the study. But in the end, even though we tested the entire nail, we really turned out we were testing the two distal inner screws, because the proximal screw didn't break. And that's a whole nother, you asked me for things I learned. The proximal screw in all of these nails was a diagonal greater trochanter to lesser trochanter, what we called first generation locking screw. That's hardly ever used today. Nobody ever uses it. And why those transverse screws are more susceptible to breakage than that a single oblique proximal screw is an interesting phenomenon. When you take a screw and you have a certain core diameter of it and you load it at 90 degrees, that's obviously different than if you take the same diameter screw, you turn it 45 degrees, the core diameter in line with the nail is actually greater, because you've turned something round made it an oval. And you don't see proximal interlocking screws break anywhere near as much as you did the distal ones with this early first generation construct, but now you do. So it is a classic thing that you try to do some research and you start asking more questions than you've answered. So I look at it that way, but we don't use those screws anymore. So it's probably a moot point at this time.
Well,
kind of turn your question around a little bit.
Sure.
If the femur was intact to below the lesser trochanter to within a centimeter or so of the true isthmus, which is, it depends on, in different people, it's a different length there. But we would just use a single proximal interlocking screw. We were perfectly happy with that. Once you get up to the lesser trochanter and the endosteal diameter gets larger, then you have more of a problem with the nail can kind of swing back and forth in that canal like a pendulum on a clock, and you get varus of the proximal femur, and you're dealing with subtroch fractures in that view. And that's a different animal, and that was not tested here.
Okay.
I know that maybe I should ask you if.
And for me, when you had this type of fracture where you weren't going to get any type of fit, where would you stop your size increasing, and what were you trying to get to, or what was your thought process in practice for clinical application of this?
Well, That's a great question. First of all, with the devices we had then, the 10mm nails had smaller diameter screws, and therefore they were weaker in terms of you know, repetitive stress. Once you got to the 12mm nails in the nails that we tested, the screws were the same diameter as whether you put in a 13 or a 15mm nail. And I think that reaming has become a little bit less of a, in my view, a little bit less of a big deal in terms of fit. I don't think it's an interference fit because you over ream these enough that, because the nails are stiff, you over ream them enough that it doesn't really matter whether you put a 12 or a 13 or 14 in maybe in terms of nail breakage in the laboratory. And I mean nail breakage, not screw breakage, but nail breakage in the laboratory, that would matter. But in real life, I don't think we see our femoral nails breaking for isthmal, for shaft fractures very often. We see that in subtroches because of the higher, compressive distractive forces there. But I think that it's not a matter of fit. I think that that's why some people only put in 12s. Now, the reason I would go bigger at times on a patient, not in this study, but on the patient, is because the bigger you are, the better aligned the fracture can be. The nail can't move. If you have an elderly lady with a massive endosteal canal, having a 15 in there does line it up better than having a 12. It does, but I don't think that mechanically it makes a big difference on whether the fracture is going to remain intact through fracture healing. I don't think that makes a difference.
Okay. Is there anybody you think was left out that should have been brought in, or vice versa?
A good question. I think that I would have done it differently because I think back then in the 90s, we were just trying to kill science with numbers. We were trying to just collect as many sequential ones as we could. And I think that that's not a very good way to do science. And I don't think your residents should see that as a good way to do science. I think that it would be better to do a study that is has much more emphasis on all the variables, some of them that you just mentioned, and maybe even put pressure in their shoes so you actually determine how much weight bearing they're doing. I mean, we don't even know that. We don't know that. And so I think that it could have been done much better. I think I look back on some of the studies we did, and basically because we were a high volume trauma center, we could just rack up numbers. It's like putting cars in a parking lot and trying to sell them. The more you got, the more people come in and look at them. Well, that's not really the best way to do science. You need a method that will try to differentiate between different variables. And we weren't really trying.
The top two thoughts about when someone asks you about this or about this topic.
I think I'm happy that I thought we kind of advanced treatment a little bit. And I look back at that kind of like we did something pretty good there. I don't think we necessarily proved it as well scientifically as we did. And I think that you then go on to the next question. And I just look at it. I'm not one who looks back and goes, kind of in an almost a sentimental way. No, we pushed it to that, and heck, we weren't even doing retrograde femoral nails back then. We had lots of things to open, lots of questions to answer. And I would just say, this is what we found. I think clinically it's been proven to be true. And let's move on to the next question.